Today we're going to continue on with Unit 1, but we're in Part 2, and Part 2 is all about chemical nomenclature. So what we're going to do today is look at ionic and covalent compounds, and most of it will be review from grade 10, but there'll be some new information as well. You'll also want your periodic table handy because you're going to need to refer to that to get element symbols, names, and charges. So first we're going to start off and define what are binary compounds, because those are the ones we're going to look at today. Binary compounds, if you're familiar with the word binary, it means two of anything. So here we've got compounds composed of two different elements. We have two different possibilities we're going to look at today. Compounds that are made up of a metal and non-metal, those are your ionic compounds. And if you have two or more nonmetals, those are your covalent compounds. And you have to be able to decide if you have ionic or covalent before going forward, because there are different naming rules depending on which one you have. So what we're going to do first is look at ionic compounds. So first we're going to take a look at some naming. What's the naming rule? The naming rule is you're going to take the name of the metal, and it always comes first. You don't change it at all from the periodic table. Then you're going to take the nonmetal, name it, but then you're going to change the ending. Instead of its normal ending, it ends in IDE. So no change to the metal name, but the nonmetal name, you have to modify it and change the ending to IDE. So let's take a look at a few examples together and see how this works. So we have a metal and a nonmetal. The first metal, its name is aluminum. So it doesn't change. But then I have oxygen. Oxygen changes to oxide. So this one's called aluminum oxide. Metal name unchanged. Non-metal name ends in IDE. So why don't you try the other three, pause the video, and see if you can name the other three ionic compounds. Right, let's take a look at these ones. This one, metal, is beryllium. And this is selenium. It changes to selenide. Next up, metal is lithium. Next element is sulfur. It changes to sulfide. You'll see pH or F used for sulfur-containing compounds. pH is Canadian, so that's the one I usually stick with. Next one, the metal is calcium. The nonmetal is bromine. It changes to bromide. So that's how we name ionic compounds. Let's continue on and look at how to write out their formulas from the name. So when you're writing chemical formulas, the metal comes first, the nonmetal comes second, and what you have to do is do that crisscross, and you crisscross the charges. Sometimes the charges are also called valences. So again, let's practice a couple together. First, we've got potassium chloride. So you're going to write the symbols for each of your elements. K for potassium, Cl for chlorine. Then you're going to look on your periodic table and look for the charge. +1 for potassium, -1 for chlorine, and then you do the switch. The ones come down, but here, since they're both 1 and the same number, you just get KCl. Why don't you try the other three? Pause the video, see if you can do them, and then we'll walk through the answers together. Next up is magnesium sulfide. So Mg is magnesium, S is sulfur, or for sulfide. They both have charges of 2. So here, since they're both the same, they're going to simplify again just to MgS. You would do the crisscross, but since they're both the same number, they cancel each other out. Next, aluminum oxide, Al and O. Aluminum has a charge of 3, oxygen 2. Do your crisscross. And you have Al2O3. Last one, sodium phosphide, Na for sodium, P for phosphide. 1 and 3 are the charges, and again you do the crisscross. So you should get Na3P. Next, what we're going to do is continue on with ionic compounds, but we're going to move on to ones where there are multiple charges, which are also called multiple oxidation numbers. So you might have noticed some elements, in particular metals, but non-metals also, they can have more than one charge. And again, sometimes charge, we call it valence, or we call it oxidation number. So any of those ones are referring to the charge. In grade 10, you would have learned one naming system with Roman numerals, but there's actually two. So what are the two naming systems that exist? One is called the classical system, and one is called the stock system. The stock system is the one with the Roman numerals. And the classical one is new, and it uses different endings. So we're going to go over the new one first. What's the classical naming system? So what happens here, as we just mentioned, there's different endings for different charges. There's an IC ending and there's an OUS ending. So if you have the IC ending being used, or you need to use it, it goes with the larger charge. So if you're looking on your periodic table and you see two different charges listed, like +2 or +3, the one that's +3 is going to have the IC ending. If you see OUS, it's referring to the smaller of the two charges. So if we had +2 or +3, +2 would be for OUS ending. Most of the time, you just have to change the ending of the metal to determine which charge is being used. But there are some elements where the name changes a little bit more than what you would expect. So we're going to walk through those ones. So first one up here, copper. Copper can have a charge of 1 or 2. When you look at copper on your periodic table, you should see those two numbers. Copper, when it has a charge of 1, that's the smaller of the two values. Copper's name changes to cuprous and uses that OUS ending. If you see copper being used with a charge of 2 instead, that's the larger number, it's going to take an IC ending, so we call it cupric. Here's another one just to show you in more detail. Mercury can have charges of 1 or 2. Here, again, larger number is 2, so we see IC ending. Number 1 is the smaller OUS ending. As we continue on down the list, you'll see again that some of the names start to change. So nickel 2 and 3 changes to Nicholas or Nicolic. Here's one that changes quite a bit. Iron. Iron, we call it ferrous or ferric. It has quite a big name change, but you'll notice the element symbol looks like the classical names. They're based on their Latin names. So there still is some relevance. It's just not the normal name that you're used to seeing. If we continue going down, here's a couple more examples. Manganese can be manganese or manganic. Tin is another common one where the name changes quite a bit, so that one you'll want to be familiar with. Stannous or stannic. Antimony is Sb, antimonous or antimonic, and its common charges are 3 and 5. Lead and gold are another two, where you see quite a big change in the name. Plumbus and plumbic, and orus and auric for gold. And again, they match their symbols there. So you never have to memorize the charges because you'll find those on your periodic table. But what you should remember are larger charge means IC ending for the metal. Smaller charge means OUS for the metal. And then any of the ones that we've just listed here with stars, those ones definitely have a name change. We can include copper in there because it's also different. So why don't you take a minute now and we're going to do some practice. See if you can try some out. So I'll walk through the first two with you and then I'll let you try the rest. So the first two here, you can see you have copper and chlorine, but there's two options here. So here you want to think about doing the reverse crisscross. If I see copper with no numbers, that implies that they're both 1 here. And here I see no number, a 1 and a 2. So where are they coming from? This 2 here has to be coming from the copper. The 1 that's here has to come from the chlorine. And we know chlorine can only have a charge of 1. So the other one here has to come from copper. If you remember doing the crisscross, if they both had a charge of 1, when you switch them, you would get CuCl like that. If the copper, though, had a charge of 2 instead, and the chlorine 1, when you do your crisscross, Cu stays the way it is, but this 2 comes down by the chlorine, and it looks like that. And that's where these two formulas are coming from. So sometimes you have to take a step back and look, what are the possible charges for copper? What's the charge for my nonmetal? And see which one's being used. So here, when I look, copper's having a charge of 1, and this one copper has a charge of 2. So now I have to decide which one's larger and which one's smaller. Since this is smaller of the two, that means I need to use my OUS ending. So when I name this one we're going to use cuprous. And then the second part of the name, like the other ionic compounds, just stays as chloride. Here, since the 2 is larger, this one's going to be your IC ending. 2 is bigger than 1. So we call this metal cupric with the classical system, and the second part of the name is exactly the same. So at this point, what I'd like to do is pause the video, see if you can try out the rest, and then we'll walk through the answers together. This is probably the most tricky part of our lesson, so make sure you take your time and see if you can figure it out. All right, so hopefully you've tried these ones out. Let's see what happens. So just a mental note here on the side. When we think about tin, when we look at tin on the periodic table, it shows as having a charge of 4 or a charge of 2. So I have to decide which one is using 4 and which one is using 2. Sulfur, I know, when I look on the periodic table, always has a charge of 2. So let's say I take tin with a charge of 4 and sulfur with a charge of 2. When I do the crisscross, I get SN2S4. But remember, you can reduce or simplify, and that's where we get this formula here. This simplifies to SNS2. I can divide both of these by 2. So here it means if I'm using number 4, it's the larger of the two numbers. So when I name this compound here, I'm going to use the IC ending. And for tin here, I have to use stannic. So this one's stannic sulfide. If I look at the other one down here, there are no numbers, so they've been completely canceled out. If I look at my options here, it must be that tin has a charge of 2 and sulfur has a charge of 2. That's how I get my tin sulfide, which is here. So when I go and name this one, I have to use my OUS ending. So this one is stannous sulfide. My last two, I'm writing out the formula. So with my formula here, plumbic is the larger of the two values. So when I look at lead, that means a charge of 4. Oxygen is always 2. I do my crisscross and simplify. Remember, I'm going to divide both of these numbers by 2. And you get PbO2. Last one, Orus is gold. OUS telling me the smaller number. So gold can be 1 or 3. So here it's telling me I have to use 1. Fluorine is 1. So this one just simplifies to AUF. And that's the classical naming system. It has its limitations because obviously it only works if there's 2 charges, which works for the most common charges. But what happens when you have multiple charges, then you have to use the other system, which is the stock system, which we're going to review next. So the stock system is the one that you would have used in grade 10, where you're using Roman numerals to indicate the valence or the charge of the element. If you remember what the charges are, we've got 1, 2, 3, 4, and 5. We're not probably going to see past 5 here, so you should be familiar with the Roman numerals for those 5 that are there. The Roman numeral explicitly tells you what charge is being used. You don't have to guess with any naming or what's larger and smaller, so it's a lot easier to follow. So we're going to jump right in. All of the other naming rules apply, and we're going to try out a few problems. So let's get these all up here. Okay, so if we do one where we're taking a formula and providing a name, again, I go to my periodic table, and when I look at copper, copper can be 2 or 1, but selenium is 2. So I see no numbers down here, so that means copper should have a charge of 2, and selenium has a charge of 2. So when I go and write my name now, I know I have copper. The metal name doesn't change. In the brackets, I put my Roman numeral 2, and then selenium changes to selenide. If I look at one where I'm trying to write out the formula, here you can see the metal name, the Roman numeral, and the non-metal name. Here it's explicitly telling me which one I need to use, so I don't even need to go to my periodic table. Gold, it's telling me use the charge of 3. Bromine only has 1 charge, -1. Then we do the crisscross. So you get AuBr3. Why don't you take a minute to try out the other two, one name and one formula. When you're ready, unpause. We'll walk through the rest together. So taking a look at these two, when we look at mercury on the periodic table, it can have a charge of 2 or 1. Chlorine can only be 1. So the 1 comes down here beside the mercury, which is why we don't see a number. But here we see a 2. So that means 2 must be used for the mercury. So I have to indicate that with my Roman numeral. So I write my metal name, mercury. I put in the 2, and then I change my nonmetal to IDE ending. So it changes to chloride. Next one, nickel to nitride. So here, They're telling us to use nickel with a charge of 2. Nitride means nitrogen. It has a charge of 3. And then I do my crisscross, Ni3, N2. So that's all of the rules for ionic compounds involving binary compounds. 2 elements in a binary compound. Always has a metal first, always has the nonmetal second. Nonmetal always ends in IDE, but there are a few varieties on using Roman numerals or endings when there's more than one charge. If there's not more than one charge, you don't need to worry about the SOX system or the classical system at all. Last one to review, what happens when you have covalent compounds? How do you name this one? It's a little bit different. Naming, you're going to use prefixes, and prefixes are added to indicate the number of atoms in each compound. Other than that, the rest of the rules stay the same. The first element name doesn't change. The second element ends in IDE, but you have to add on these prefixes. So let's review what they are. So here's the first 5 to start. 1 is mono, 2 is di, 3 is tri, 4 is tet or tetra, depending on whether you have 2 vowels or not. You could say pent or penta for 5. There are a few more. Hex or hexa for 6. Hept or hepta, and you get the idea. Oct or octa for 8. Non or nona for 9, and dec or deca for 10. There are a few rules though when it comes to 1 and the prefix mono, so you want to watch out for these ones. So mono is often only used for the second element. If you only have 1 atom of the first element, we omit it, we exclude it. But we always use it for the second one, which can get a little bit confusing. So we'll look at that with an example here. So here are a couple to name. So I see I've got 2 nonmetals, so it tells me covalent, and I have to use the prefixes. 2 means di. Then I write the name of the first element unchanged, so that's just phosphorus. So diphosphorus. Then I have oxygen, which will change to oxide, but since I have 5 of them, I'm going to use pent, not penta, because there's a vowel here, and it's pentoxide. Why don't you try the next 2, just for some added practice, and when you're ready to check, unpause the video. Next one, carbon and oxygen. So here's 1 carbon. This is one of those cases where we don't use mono at the beginning. So we just say carbon. But there's 1 oxygen, the second element, you include it. You don't put a double O for mono and oxide, it's just monoxide. Carbon monoxide, you've probably heard of that gas before. Last one, 2 hydrogens and 1 sulfur. 2 hydrogen is di. So dihydrogen. Second one of them, monosulfide. Now what you might notice in practice after you're working on some problems, hydrogen can sometimes be treated as covalent when there's 2 nonmetals, but sometimes it's also treated like an ionic compound. So sometimes we also just call this hydrogen sulfide. So hydrogen 1, that's a little tricky. Sometimes you also just see hydrogen sulfide, and it takes on more of that ionic naming that we just went through. So watch for hydrogen, it can flip-flop back and forth, and both would be acceptable. Very last part of the lesson, what if you have a chemical formula that you want to write from a name? So this one's one, again, that's slightly different. You don't have to do the crisscross method here. For every other formula that we write, we use the crisscross method, but here, don't use the crisscross. Just look at the prefixes. So for example, sulfur dioxide. I see a di here, which means I have 2, and nothing here, which means I have 1. So when I write my formula, I have 1 sulfur, 2 oxygens. I don't need to crisscross or do anything. Next one, I've got 1 carbon, and here tetra means 4 chlorines. So when I write my formula, carbon with 1, chlorine with a 4. Last one, when I look, diphosphorus trisulfide, di and tri. Di means 2, tri means 3. 2 phosphoruses, 3 sulfurs. So these ones are the easiest when it comes to formula writing. Don't do the crisscross, follow the name, and you'll be set.